Hello everyone. So we are continuing with the same chapter, Boolean algebra, continuation of the previous video, and in today's video we'll discuss about POS, that is product of sum, and conversion of sum of product to POS and POS to SOP, right? So product of sum form, POS form. So a canonical expression composed of max term is called product of sum form. So canonical expression, so this is a canonical expression, and here it is composed of max term. So max term, as you can see in product of sum, okay, product of sum is signified by this max term. In the previous video we have seen the sum of product, and in the sum of product the canonical expression was composed of mean term. So mean term is represented by SOP, and max term is represented by POS. So mean term is represented as SOP, where the variables or the terms are multiplied by AND operator, and in max term you can see you use the OR operator. So here you can see that the function f equals to x plus y plus z and x complement plus y plus z complement and x plus y complement plus z complement. So this is a product of sum format, right? So using a truth table, a Boolean function f output can be expressed by forming a max term for each combination of variables, which produces an output 0 in the function, and taking AND of all the terms, which is the literals of variables. Okay, so here in the next page we will see a truth table where a Boolean function output will be expressed by forming a max term. So in the previous video we formed a mean term, so here we'll form a max term that the output combination of the variables which produce 0. So when it produce 0, we'll take the max term of it from the function, and then we'll take the we'll evaluate it using the AND operator, right? So here given truth table expresses the function, okay, f x comma y comma z in POS form. So we have to here is the truth table. So you can see that three variables, and the values you can have only two values, that is 0 and 1. So since there are three variables, it can have up to 8 combinations of input values, that is 8 combinations of rows. So as you can see that using 0 and using three variables and then using the two values 0 and 1, you can form only maximum of 8 rows, so possible combination. So here is the function output, right? So from the given table, the function which produces output 0 are, so here, so this is the solution table. So here we have to find the max term. So the function which produces the output 0, not 1. In mean term, we find the mean term from the function which produces the output 1, but in terms of max term or POS form, the function output which is 0, we find the max term of it. So here you can see that the value which in the when the input value is 1, we take the complement of that literal. So as you can see here in this row, x is 0 and y is 0, so that's why x and y, they are uncomplemented, they remain the same. So x plus y plus z complement, because z here is 1. So since z here is 1, so it we complement the value of z, so z variable. So in terms of mean term, if it is 0, then in terms of mean term, if it is 0, then it will be, say, like x complement plus x complement dot y complement dot z. It will be like that. So here again, here in the third row again it is 0. So here x is 0, y is 1, so that will be y complement, and z is 0, so it will remain same. Then in the fourth, fifth, sixth row, so here x is 1, so x complement, y is 0, so plus y plus z complement, because z is 1, so we get this max term value. So here you can see that in the last line also, that is 1 1 1, so x complement plus y complement plus z complement. So for the max term in terms of POS form, we take only the max term value where the output value is 0. So in terms of the designation, that is here the decimal values here are 0, that is this 1 2 3. So in terms of max term notation, it will be capital M0, M1, M2, M3, M4, M5, M6, M7. So altogether you have 8 decimal values, because 3 variables are there and you can form only 3 rows, right? And 8 possible combination of values. So now, taking end of all the max term form, the expression in BOS form from the above table is, so you can see here that we take the end of this max term form, so that's why we multiply it, x plus y, okay, and then x plus y complement plus z dot x complement plus y, like this, okay. And then what we do is that we take in the designation, so in which row it is. So to represent POS form, we use the symbol pi. In terms of SOP, we use the symbol summation, that is sigma, so that is sum of product. But in this case, to represent the product of sum, we use the symbol F equals to pi, okay, and the x plus y plus z complement is represented by the designation 1. So we write down the 1 2 5 comma 7. So this is the canonical POS form. All right, canonical POS max term form. So we get this canonical POS max term form in this notation. Now converting SOP into POS and vice versa. So the complement of a function as the sum of mean term is equal to the product of max term missing from the original function, right? So here the complement of a function, so in this case this is the function, as the sum of mean term. So this is the sum of mean term. As you can see that here in this particular example, this represents the mean term, the sum of mean term, and here these are the rows of the mean term. So these here 3 variables can have 8 rows, that is so here it will be 0 to 7, okay, 0 to 7. So that means 0 1 2 3 4 5 6 7. All right, so altogether it forms 8 rows, right? So here sigma represents the summation of all these rows, okay. And then number of rows depends on the truth table, that is in terms of mean term, if the output is 1, then we take in the summation of that, right? So it's based on the truth table. So what we do is that here, as the sum of mean term is equal to the product of max term missing from the original function. So in this function, this is the mean term rows, but now according to this definition, the equal to the product of max term missing from the original function. So these are the number of rows which are missing from this mean term table, right? So that is equal to the max term, right? So now let's prove that. So here, according to this definition, it is f x comma y comma z is equal to summation of, okay, 0 2 4 7. Now this number of rows here, you have 4 rows or 4 values. It depends on the truth table. Actually, it depends on the truth table where the number of ones are generated. So it may you so 3 variables. Okay, so here 4 rows and 4 rows, so together 8. So here you may have only 0 to 4, or you may have 0 to 7, or you may have 0 to 4 5 7 also. In that case, if you have 5 numbers here, it will be 3 numbers here, right? So now based on that, complement of a function. So complement of function is f complement x y z equals to, okay, so is the sum of mean term equal to the product of max term missing from the original function. So the rows missing from the original function is this, right? So in this function, these are the rows 0 2 4 7, but the complement of that is, okay, the complement of this function is is the sum of the rows which are missing from the original function, right? So that is 1 3 5 and 6, right? So these are the missing rows on the mean term of this function. So the complement of this will be this. So now if we have to find the designation of that, it will be, in terms of mean term, it will be m1. Mean term is represented by a small letter m, right? So m1 plus m3 plus m5 plus m6, right? Now what we do is that we have to prove this sum of mean term is equal to the product of max term, right? So we do it by using the De Morgan's theorem, again taking the complement of f complement. So f complement, the whole complement, equals to, right, m1 plus m3 plus m5 plus m6 complement. Okay, so now using the you know that in De Morgan's theorem, that is like x plus y the whole complement equals to x complement into y complement, or x into y the whole complement equals to x plus y the whole complement, right? So we can use this SOP POS or POS to SOP by using the De Morgan's theorem. So here you can see that we using the De Morgan's theorem, that is x plus y, in this x plus y the whole complement format, okay, we can change it into x complement into y complement, like that. So here using the De Morgan's theorem, we change that to m1 complement into m3 complement and m5 complement and m6 complement, right? So if you see the then if you go back to the product of sum, okay, the product of sum expression, you will see that, okay, the product of sum is in this format. So now since product of sum represents the max term, so we can convert this mean term to max term, that is capital M1, okay, dot and M3 and M5 and M6, okay. So that will be represented by, so we know that x complement, the whole complement, equals to x, right? So that's why we get the value f, okay. So f equals to pi 1, that is the designation 3 5 and 6. That is, if mi is the mean term, so this is the mean term for ith rows, and mi is the max term for ith rows, then, okay, mi the whole complement equals to mi. So which proves that the sum of mean term is equal to the product of max term missing from the original function. So you can see that the sum of mean term, okay, the sum of mean term is equal to the product of max term. So this is the max term, right, missing from the original function. So you can see that here you have 0 2 4 7, and here you have 1 3 5 7. So this can also be done for product POS to SOP, okay, where we can find the product of sum to sum of product. So go through this example nicely, okay, and go through the POS and check the previous video also where I've explained the SOP. So SOP and POS is very important, okay, and then from there you will move on next. In the next video I'll discuss about the K map, that is the Carnot's map, right?